So I think we're going to get started soon. Everybody can hear me okay? Nodding heads, that's good. Okay. All right. So hey everyone. Thanks for coming out to my talk diving deep into JavaScript functions. I'm really excited to be here and really excited to be giving this talk. So quickly before we start, a little bit about me. This is my picture. And my name is Colin DiCarlo. I'm living as a software developer, and I work primarily with PHP and JavaScript. On Twitter and GitHub, I'm Colin DiCarlo. So I'd be lying if I said I didn't want you to follow me. So you can check me out. I do a lot of retweets, and I contribute to some open source projects. So follow me where you go. I work with a very talented group of people at Vehicle in Waterloo, Ontario. Vehicle is a software consultancy, and we specialize in developing apps with Laravel on the back end and Angular on the front end. And so if that sounds interesting to you, good news, we're hiring, we're growing, and my wonderful supportive bosses are sitting in the back there. For the past 4 years, I've also helped organize the GPub PHP user group. We meet on the last Wednesday of every month, and generally have 1 or 2 talks given by speakers of a similar caliber that you find here at True North. So check out GPub at meetup.com. You can join our Slack channel at gpub.ca and come on into a talk. Also, going back to what Chris said earlier today at the opening keynote, if you're a speaker or if you want to be a speaker, user groups like the GPub are a great place to get started. And so if you're interested in giving a talk and you're local, hit me up and we'll see what we can do to work it out. So why am I doing this talk? And more importantly, why do I think that it's worth your time to listen to me? You know, that's an interesting question. When I look at speakers that are giving talks at conferences like this, and I read their abstracts, I'm always curious as to what led these people to put their talks together, submit them to conferences, and put themselves out there. What was it that happened in their lives to make them think, other people need to know this? And so for me, my motivation in doing this talk is that JavaScript is a really deceptive language. It looks like a C-style language. It's got ifs, else, whiles, switches, semicolons, etc., etc. So an unknowing developer would expect JavaScript to behave like a C-style language, like PHP or something like that. And the really deceptive part is that JavaScript can and probably does, when you start working with it, behave in the way that you expect. And it's only until you start getting a little bit more involved with your JavaScript programs that it starts showing its own colors. And you get in this position where you thought you knew what was going on, but you don't really know what's going on. And so that happened to me a few years ago. And it was kind of like running into right into a brick wall. I thought I knew what the JavaScript runtime was doing. I wrote the code and I saw it and I'm like, I know what it's going to do. It's going to read this code, it's going to operate in this way. And when it became painfully obvious to me that JavaScript wasn't operating the way that I thought it was, I needed to remedy that situation. So what I did was I read the good parts, and then I waded my way through the Rhino book, which is massive. And then I read the good parts again to remind myself why I actually wanted to learn this language. And I also did a lot of exploratory programming. And one of the things that I was able to distill out of that entire process is that JavaScript functions are vastly different than their C-style counterparts. And when it was when I came to that understanding that I kind of figured out how the rest of the language worked. And so also when I came to that understanding, I immediately forgot how hard it was to figure that out. And I assumed everybody else that I was talking to also had this information in their heads. And it really wasn't until I started talking to my peers about JavaScript functions that I got an inkling that maybe not everybody does know how it works. And that was my everybody needs to know this moment. So I put the talk together. I gave it at work a couple times. I gave it at the GPub. And now I get to give it to you. So I hope you enjoy it. The talk itself, though, as you can probably tell right now, is pretty technical in nature and pretty involved. There's a lot of code snippets, and I can't seem to stop myself from asking people if they understand what's going on before moving to the next slide. So if you do have a question, please ask. I'd rather finish the talk halfway through and have everybody in the room knowing what's going on than finish early and have a room full of people wondering what the fuck just happened. So this is our agenda. We're going to start things off at a really fundamental level and talk about exactly what a JavaScript function is and how it's represented. Starting here will hopefully provide a good contrast to how JavaScript functions differ from their C-style counterparts. Next, in how do I create these functions, we're going to talk about the different ways that you can create a function in JavaScript. And talk about the circumstances and scenarios that might drive you to choose one way or the other. The bulk of the talk though is going to take place in this third section. What happens when I invoke a function? We're going to go step by step through a simple function and examine what really happens. In this section, I'm going to go over things like the execution context and scope chains, how to know what this is going to refer to when your function executes, and the order in which variables and functions are declared. Finally, we're going to wrap things up by showing a few examples of how to make use of what we just learned, and we're going to see how we can change what this actually does refer to, how we can make specialized versions of functions using partial application. We're going to touch on how real closures work, and how to encapsulate objects, data, and behavior. Oh, shit. Starting fresh. Wrong button. So what is a JavaScript function? So much like everything else in JavaScript, functions are objects. And so since functions are objects, they get to have their own properties, their own methods, and their own big P prototypes. So this is very different from what PHP does, and it took me a while to get comfortable with. So here's a function add, and it has these properties and methods. So when we define add, it creates an object, and then it associates properties to that object. So the name is add, and we can tell what it is, and it has length too. Now, how does a function have a length? Well, the length of a function is represented by the number of formal parameters that the function accepts. So we can see that add takes two parameters, x and y, so its length is 2. Now the methods that add actually has, it inherits from its prototype function. And it has a bunch of them, but some of the more notable ones are call, apply, and bind. And then it also inherits the toString function and other functions from the object prototype. The toString function in particular is one that I find really useful when I'm at the debug console in my browser. If I want to know like where a function is defined or how it works or something like that, I'll just type it up, hit toString, run that, click on it, and it brings me right to where it's defined. So it's really nice. It's a good little tip. So, actually moving back, sorry. Functions are first-class citizens. Functions are first-class citizens in JavaScript. So what that means is that they can be assigned to variables, they can be passed to other functions as parameters, and they can be returned from functions. And that's really important. That's what helps make JavaScript so expressive. So how do I create these functions? Good question. So this is a named function. And named functions are probably going to be the first type of function that you start working with when you start working with language. And if you're coming from PHP, named functions look really familiar and they can be really easy to wrap your head around. As you start working with JavaScript though, something you might find is that your use of named functions drops off and you start using function expressions or immediately invoke function expressions or something like that. One of the things that I've found using named functions for recently to be really useful is as a way to encapsulate really complex logic in a nice semantic name and define that named function as an inner function of another function. So function expressions. So since functions are first class, they can be assigned to variables and get passed around. So I find that function expressions like this are some of the most common type of functions that you'll see in JavaScript. They get used as callbacks, they get assigned to object properties, its methods. They can just get assigned to plain variables like this. And really I find this almost like muscle memory to type var foo equals function. One specific reason you might use function expressions over named functions is to compensate for differences in various JavaScript runtimes. So when your application boots up, you can introspect or interrogate the environment, find out the capabilities that it has, and then you can change your program on the inside while still offering the same API to your end user. One caveat, however, about when you're working with function expressions is that it can be difficult to debug when things go awry. If you have callback on callbacks on callbacks, and you look at your stack trace, you'll just see anonymous function, anonymous function, anonymous function. One of the ways that you can work around this is by using named function expressions. So you would have var function expression equals function expression. And then when you look at your stack trace, it will give you the name of that function in there. So it's a little bit more helpful. So, immediately invoked function expressions. Not necessarily a different type of function, but a different application of a function expression. So as the name suggests, an immediately invoked function expression is invoked as soon as it's defined. And so they're useful in cases where you want to create sort of like a sandbox for your application to run, or for the function to run inside of. So immediately invoked function expressions are kind of like a blip on the execution stack. They get created, they run, and they get thrown off. So this is what I call a palette cleanser. We're going to run into these periodically throughout the talk. We're going to take those short breaks to kind of digest what we just learned. So we're going to run into these every now and then. Does anybody have any questions? Yeah, everything's pretty clear? Everybody's watching the kids just do shit. Nice. So what happens when I invoke a function? Good question. All right. So if you remember our add function that we defined a few slides ago, the most natural way to invoke that function is to refer to its name and then append some parens to it with a comma-separated list of arguments. When the interpreter sees this, the first thing it's going to do is create something called an execution context for the function to execute inside of. Next, the scope chain that existed at the time the function was defined is loaded into the execution context. And this is where JavaScript gets its lexical scope from. So what it means is that the function, when it executes, will have access to all the symbols that existed in the scope chain at the time that it was defined, and not the time that it's invoked, which can be much later in your application, especially if you're booting up your application, registering all callback handlers or things like that. It's not like a couple minutes later that it gets executed and handled by some observer. Following that scope chain being loaded, the interpreter creates another object called the activation object. And the activation object is loaded with a number of items that are unique to that specific invocation of the function. It's then linked into the front of the scope chain, which makes it the first thing that's searched when the interpreter needs to look up references. Finally, the execution context is thrown on top of the execution stack, and the function code is run. Once the function completes execution and returns, the execution context is popped off the stack, and control returns to the function which called our function. Are there any questions? Al. Sorry. I love kids. So, scopes. Before we got talking about the activation object, I think it's a good time to discuss scopes. Technically speaking, the scope chain is rooted at the global scope, which is called the variable object. And it's a linkage of activation objects contained in the execution stack. So when you reference a variable or when you reference a variable in your code, the scope chain is traversed, starting at the activation object, the closest scope, and it traverses up the scope chain until it finds the symbol that it's looking for. If it doesn't find the reference to symbol that it's looking for, it just returns undefined. It sounds a little complicated, but in practice, it's not that bad. So let's run through an example. So let's pretend that we're the JavaScript interpreter. So we're going to start at the top of the file and we're going to read down. So we've got our variable object, our global scope, which is right here. And we're reading here, we say, oh, global var. So we're going to throw that into our global scope. Then we're going to say, oh, there's a global function here. I'm going to throw that into my global scope as well. I'm just going to say it's a function. The next thing that we're going to run into down here is we're going to invoke global function. So when we invoke global function, what we do is we go and we build up our activation object, we link it into the scope chain, and that becomes our closest scope. We're going to call it our global function scope. And then we start declaring variables and functions that are inside of it. So we're going to say, here's our local var, so that exists inside our global function. And here's another function which is defined in here, and that's just going to live here. Moving through, we're going to execute inner function. So we do what we do when we execute functions. We create another activation object, we link it into the scope chain, and that becomes our closest scope. Now we're going to look inside inner function, and we're going to declare another variable found in inner function. And now we're actually going to do something. We've done a lot of setup, but now we're going to run. And we see console.log, global var, and inner var. Then we're going to call console.log, not found anywhere. So when we log this out, we're going to say global var. Okay, well, where does that exist? And we're going to start looking in our most recent scope. It doesn't exist there, so we're going to traverse up the scope chain into global functions. It's not there, so we're going to go up again, and we're going to find it here. And we're going to log out, found in global scope. We're going to do the same thing with local var, but we're going to find it here first. So we're not going to have to go up here, and we're going to log out found in global function. Inner var is going to be found right here. We're going to log out found in inner function. And now when we look for not found anywhere, we're going to do the exact same thing over again. We're going to look at this scope, it's not there. Traverse up this chain, it's not there. Traverse up the chain, it's not there. So it's not defined. So we're just going to return undefined. Yep.
Once you get past inner function and get to the end of the function, is that scope disposed of, or is that still retained? Because I know from PHP it's still in the symbol table after you execute a function.
So when we
once you hit just after inner function semicolon, so say we have another line of code, would the inner function scope still exist in our execution context, or
no?
No.
So what will happen is, think of this as the execution context for inner function. So it's going to exist only as long as inner function is running. Once inner function is done, it's going to get popped off the execution stack, and it's not going to exist anymore. So, well, the GC will be able to reclaim it once the GC runs. GC being garbage collection. All right. I love this one. It's so good. I'm so terrible at skiing that I totally relate to this game. All right. So let's talk about the activation object. So as mentioned earlier, the activation object is created each time a function is invoked and placed at the front of the scope chain. It's loaded with all the variables and functions that are declared in the function, a special object called arguments, and a reference to a keyword called this. So let's step through an activation object being initialized and take a look at what happens when we invoke our add function. So the first thing that happens is that this is loaded into the activation object. In my opinion, this is one of the more confusing parts about the language. And for me, that's pretty evident when we're almost conditioned to write var that equals this before we enter into an inner function or define a callback. So this is such a pain in the ass that we actively try to circumvent it, and nobody bats an eye when we see that. So part of what makes this so confusing is that what this actually refers to is based on how the function is invoked. There's various scenarios. The good thing is, though, that there's rules for these scenarios. So let's step through them. So a function which is simply executed. So when a function like this is invoked by itself, this is going to be one of two possible values. So it's going to be the global object or undefined. And the thing that says whether it's the global object or undefined is whether or not we are using strict. So if we're using strict, if we're in strict mode, this, when we execute something complicated, will be undefined. If we're not in strict mode, this will be the global object. So it's typically, though, when you're just writing a function to be executed like this, to not reference this at all. Treat it like a static function, like that exists on like a PHP class or something like that. It has no state. You're just using it to do some action. Don't reference this. Any questions? No palette puns, we're moving on, sorry. So, functions as object properties. So here we have an object literal called calculator, and calculator has two properties. Debug, which we set to true, and something complicated, which is a function expression. And so object properties, like something complicated, are more commonly referred to as object methods. And when a function is invoked this way, this will refer to the object which the function belongs to. And the easy way to remember this is to use the mnemonic left of the dot. So what that means is when we look at the dot and we look to the left of it, that's what this is going to refer to. So in this instance, this is equal to a calculator. Elements as attributes, or as element attributes. So back in the olden days of the World Wide Web, this is a bit of a history lesson. Webmasters would mix behavior with their markup. They would do this by specifying actual JavaScript code in HTML elements like this, or attributes. And so in instances like this, this will refer to the HTML element that the attribute belongs to. So in this case, this refers to this button element, calculate. It's got the ID, calculate. So the Wayback Machine tells of a great bubble that burst. And with that, all of these webmasters were destroyed, and their code was wiped away in the great rewrite which followed. Functions as event handlers. So when functions are used as event handlers, this will refer to the event target. So an event target can be a specific element, the whole document, or even the window. So in this case, this, like in the last time, will refer to our calculate object here. In a constructor function. So circle here is a constructor function. And we know that circle is a constructor function because it has a capital C. So you're scratching or you have a question?
Nope.
All right. No scratching. So we know that C is, we know that circle is a constructor function because it has a capital C. And so the interpreter doesn't care that it has a capital C. So it's purely semantic, and it's just meant for us. And so it's like a warning. It says, if you're going to be executing this function, put new in front of it. Otherwise, bad things are going to happen. So without going too much into how new actually works, using new will cause this to be an instance of circle. And so what that means is it inherits from circle. And so that's what it is. This is an instance of circle. Are there any questions so far? This is great. Everybody's getting it. It's fantastic. I'm doing a really good job. Ballot punter. All right. So we're going to move on to arguments. So the arguments object is the next thing that's loaded into the activation object after this. Arguments is an array-like object with numerical properties. So the properties correspond to the arguments which were passed into the function when it was invoked. So an arguments object can have more or less properties than the function has formal parameters. So in this instance, when we're invoking add with 2, 3, arguments is loaded in the activation object with two numerical properties. 0 here, which is 2, and 1, which is equal to 3. So if you were to call add with like 3 parameters, for instance, like let's say you called add with 2, 3, and then 42, arguments would have 3 numerical properties ranging from 0 to 2. So 0 would be 2, 1 would be 3, and 2 would be 42. Arguments also has a length property on it, which corresponds to the number of numerical Properties are a number of parameters that were passed to the function. And so knowing that, we can do a lot of like really great things with variadic functions. And I'll get into an example of that in just a bit. So name formal parameters. So this is really simple. Name formal parameters are just a really fancy way of saying the parameters that the function was defined with. So our function add x, y has two name formal parameters, x and y. And so when the function is invoked, those variables are mapped to the arguments or the parameters that are passed in. So x, again, is equal to 2, y is equal to 3. We're good? All right. Declaration and hoisting. So finally, the last items that are loaded in the activation object are function declarations and then variable declarations. So this is known as declaration and hoisting. So the variables are, one thing to make note of is that when the functions are defined, the entire function is defined. But when variables are declared, we just say, hey, there's going to be a variable here called x, and there's going to be a variable here called y, or in this instance, there's going to be a variable here called I, and a variable called words. And so they exist, but they're not assigned. So they're undefined until they're actually assigned in the actual application. So that can lead to problems. For the most part, it probably doesn't, but just a heads up there. So the term hoisting is used because you can think of a function definition and variables being lifted to the top of the actual function. So the interpreter sees this, but sort of you can think of kind of rewrites the function. So instead of looking like this, it looks like this. So just to step through this real quick. So we can see this is what our old function was. And the first thing that we did in the old one was we returned. But now, after declaration and hoisting, we took the to array and we moved it all the way up to the top. And then in our old function, we had bar I over here and bar words over here. But because the variable declarations were hoisted up to the top of the inner function, they're here and here. This is kind of what it looks like. We're okay. So hoisting actually just has one simple, oh yeah?
Is that happening inside the activation object?
So, yes, like the function itself doesn't actually get redefined and rewritten in that way, but by the order in which things were loaded in the activation object, it's pretty much what happens. Does that make sense?
Yeah, does it have any side effects?
It can. And so basically what that means is like, let's say, like, they'd be like really weird, sort of like Heisenbugs, but like, let's say you have a loop variable I, and so you have this loop for I equals 0 or something like that. And then you were doing some refactoring, and previously you had like a variable I that existed like outside of it or something like that. You're not going to get like an error saying like, hey man, I doesn't exist, right? Because I does exist, right? So you can run into things like that. So hoisting does have one simple rule though, and it's really easy to follow. Just don't do it. Declare all of your variables, all of your functions at the top of your function definitions. And you're not going to run into problems like that. Good? Palette cleanser. This is one of your favorites. All right. So let's recap. What happens when I invoke a function? We're not going to go through it again, we're just going to recap. Okay. So the first thing that happens is the execution context is created and is placed on top of the execution stack. Next, this and arguments are declared and assigned. Then, named formal parameters are declared and assigned. Then named functions are declared. So they go up with their entire definitions. And then local variables are declared, but not assigned. All right. So how may I wield this power? So it was probably a lot to take in, but it's about to get worth it. Now that we know exactly what happens when a function is invoked, we can use that knowledge to make our code better, gain friendship, impress people at bars, you know, those sorts of things. So let's look at variadic functions and see how we can use arguments to our advantage. So I want to write a function that returns me an enumeration. And the enumeration is going to have values in it that my program can use towards validation. So for instance, let's say I'm running a custom t-shirt business, and I only stock shirts that are red, green, and blue. And I want to be able to take a customer's order and say, hey, is this a t-shirt color that I stock? So this is how we want to interact. So we've defined our API, this is how we want to interact with it. We want to say, hey, I want to make an enumeration, and then I want to be able to ask it, does it contain that color? And I want to say yes or no. So in this instance, if I say the color is red, and I say, hey, does it contain red? I want to say, yeah, it does. If I say yellow, and I say, hey, does it contain yellow? I want to say, no, it doesn't. All right, so here's our function. So this is enumer. And what we do is, first we declare all of our variables that we're going to use because we're not going to take care of, we're not going to worry about replacing them. And so we're going to declare our loop counter, the number of values that we're going to have in our enumeration. We're going to set that equal to arguments.length. So however many things they pass in here is going to be set to no values. And then we're going to have an object literal here, which is actually going to be, it's going to represent our enumeration. Then we're going to enter into a for loop, and we're going to iterate over all of the arguments, and we're going to assign the properties to the values that were passed in. So when we invoke something like this, enumer red, green, blue, values is going to end up being an object that has a property red with a value red, a property blue, with a value blue, and a property green with value green. Next, what we need to do is we need to build in that part where we can say, hey, does it contain this? And so we're going to do that first by defining the function contains up here. And we're going to say, when we ask it, does it contain something, we're going to say, hey, do we have this property? So this is something that's inherited from the object prototype. And we say, hey, do you have this property in you? And it will return true or false, whether or not it does. And then what we're going to do is we're going to take this contains function and we're going to assign it to the contains property on values. Finally, what we're going to do is we're just going to return values as our enumeration. So values is going to have a number of properties and it's going to have a function that called contains. And then we can say colors.contain selected colors, and it's going to say true or false. And that's how we can write a really useful variadic function. Are there any questions about that? All right. Maybe I'm waiting not long enough, but that'll be fun. All right. Let's talk about modifying context, or really taking control of this. So earlier we learned how JavaScript defines what this is going to be based on the circumstance that the function is invoked. However, the function prototype gives us 3 methods that we can use to say, no, forget any of that. This is what I want this to reference. So the first method is call. And call is used to set the value of this when you know what the arguments are, and you know how many of them you're going to be using. So one specific use case for call is to call super functions, so functions that exist in an object's prototype that you've overridden in your own instance. Also, a very practical and common use for call is to take the arguments object, which exists in our activation object, and turn it into just a regular array. And so I'll show an example of that in just a little bit. Apply. So apply serves an identical purpose as call, but it differs in the way that the arguments are passed to the function which is being invoked. So where call requires you to know what the number of arguments are, what they're going to be. Apply only requires that you pass in an array of arguments to be passed to the function. So a common use case for apply is if you want to decorate a target function for some specific purpose. Like let's say you want to log that a function was called with certain arguments. You can do that. Maybe you want to debounce a function that taxes your browser. Or maybe you want to memoize a function that has to run a really expensive other function or something like that to calculate a result. So you can use apply to wrap that function with a decorator function. Okay. So bind. So bind differs from call and apply in that the target function isn't actually executed right away. So basically what happens is that bind will always return a function to you that when that function gets invoked, this in that function invocation will be whatever you told it was. So a common use case for bind in event handlers is, well, a common use case for bind is when you're using them in event handlers. So remember that when you're executing an event handler, this is going to be associated to the target, the event target. And so if you, sometimes that's just not useful to you. You don't care that this is that event target. And you want it to be like maybe the object which registered the event handler, something like that. You can use bind to say this is going to be the object that registered it. Bind can also be used for partial application, and I'll show an example of that a little bit later. All right. Couple more palette lines. All right. So, yeah, like that? Let's see if we can play it. Okay, so here's a memowise decorator function. So as I mentioned earlier, memowizing is a way to save the cost of needlessly calculating an expensive operation if the arguments that are passed to a function are always going to produce the exact same result. So a really good example of that would be like the Fibonacci sequence. It's kind of like a classic example. Like if you're going to calculate Fibonacci sequence of 6, and then you're going to calculate the Fibonacci sequence of like 10, if you already know what the numbers are from 0 to 6, you don't have to recursively call Fibonacci all those times. You can just say, oh yeah, I remember what that is, and return that value. So here's a function, memowise, and it's gutted of all the interesting bits in the wrapper function, so we can just focus on what the wrapper decorator does at first. So what it's going to do is it's going to take in func, which is the function that you want to wrap, and context, which is the context you want, or this. You want this. The context is what you want this to be when the function is actually invoked. And we're going to declare our results cache right up here, and then we're going to declare a wrapper function, which is going to wrap the function which we are memowizing, and then return that. So basically, the wrapper function will take the place of the function in which you're memowizing. So it presents the exact same API, it accepts the exact same parameters that the function that you're wrapping does, and nobody's none the wiser that you're memowizing it. So here's the interesting bits of how we actually do this. So first things first, we're going to use call to take our arguments that was passed into the function because we don't know what they are, and we're going to turn them into an array. So basically the way we do this is we say array, prototype, slice. So this 3-word thing here says, hey, there's a method called slice that exists on array, and I want you to call it. And instead of calling it, and when you call it, I want arguments to be the thing that you operate on. Start at the index 0 and just go all the way to the end of it. And so what that'll do is it will give us back all of the arguments instead of an object as an array. Then what we're going to do is we're going to make a key, like a unique key to represent this set of arguments that the function was invoked with. And we're just going to do that really simply just by concatenating them together with a colon. So what we're going to do when to check to see if we've already executed the function before, we're going to look at our results cache. We're going to say, hey, if the results cache doesn't actually have this key, then we're going to have to execute the function. So we're going to enter into here, and we're going to use apply to call that function. We're going to say, use the context that you told me to, and pass it the args that we created when you run it. That's going to run our expensive function, and we're going to store the results in our cache at that key value. Now that we've done that, we can return the result from our cache. Does that make sense? Everything's clear there? Excellent. Let's talk about partial application. This one's pretty cool. So partial application is the process of taking a function which accepts n arguments and turning it into a function that accepts n minus x arguments. So you can use partial application to simplify how a function is called if some of the arguments that it accepts are constant. They're always going to be the same thing. So partially applied functions can also be given a more meaningful name, which makes code easier to read. So here's a contrived example for our add function. So we've got our original definition of add right here, add xy. And what we want to do is we want to create a function that no matter, that just tells us what 42 plus any other number that you pass me is. So we're going to do that by using bind. So we're going to say that the variable plus 42 is going to be equal to a function that is the result of binding add to the first parameter 42. So note here one thing though is that I'm passing undefined as this R to bind, and that's because in add we don't reference this. So this is my way of telling bind that I just don't care. I don't care what this is because I'm not going to reference it. So when we do that, we have plus 42 and we execute it, we get 84. It's pretty neat. We're good? Excellent. All right. So closures. All right. Talking about JavaScript functions probably just wouldn't be complete without discussion closures. Typically, a closure is described as a function which closes over a variable from an outer scope. And semantically, that's correct, but it's not technically correct. So really, what a closure is a function which holds a reference to another function's activation object, thus allowing that function to access variables and functions defined within it. So it's a little more palatable if you say it just closes over a variable, but this is probably a little bit more correct. So you create closures by returning functions from within functions. So let's see an example of that. So here we've taken our plus 42 method to a whole new level and created a plus x method. And so plus x will accept any number and then return a function that when you invoke that function will add x to it. So now what we can do is we can create any number and we can create like a vast array of very specific adder functions. So the closure here is the function expression right here. Which is returned from plus x. So since the function expression is defined inside plus x, it holds a reference to plus x's activation object in its own scope chain. So plus x's activation object will have the variable x inside of it, which will be accessible to our function expression when it's invoked. So getting to your question, I think, about does it get like popped off the stack? So basically the reason that we still have access to x after a function gets returned is because the function here, this function expression, has the activation object in its scope chain. And then so JavaScript at the time says, oh, well, I don't know if that function is ever going to reference anything in that scope chain, so I can't GC it. I have to hold on to it. So that's how a closure works. So what we can do here is we can make our own 42 just by saying plus x 42, and then we call plus 42 1, and we'll get 43 back. We're good? Yeah. All right. Oh, yeah.
Those two separate scopes.
Let me see what I can get to. Yeah. So, all right. So when we define plus x, what happens is plus x says, okay, it holds onto its scope chain, and when we invoke plus x, it creates that activation object. And along with this arguments, x gets loaded into the activation object, and the only thing that it does is it returns this function expression. Now, in order to return the function expression, we have to create the function expression first. So we have to create that function object, and when that function object is created, it captures a reference of the scope chain that that exists at that time, which what it would look like is, in this particular instance, the global scope, and then plus x's activation object, which it just includes as its scope. Did that answer your question?
A little bit. Like in the beginning of your talk, you referenced name expressions within name expressions, and they each have their own scope.
Yes.
I was wondering if that inner function there, that closure, had its own, and it just passed the activation object into it, or if it share the same scope.
No. So it will. Its scope chain. It kind of like has a pointer into the scope chain. It says this is where my scope chain starts.
Yeah.
And so when it gets invoked, so when the result of this function, so when we invoke plus x here, so let's run through it. We have plus x 42. So what's going to happen is plus x is going to be invoked. We're going to create that execution context. The scope chain of plus x is going to be loaded in. The scope chain at this point for plus x is just that global scope. And then the activation object is created and it's linked into the scope chain. The activation object will have x inside of it, which is 42. And then we're going to return, we're going to actually run the code that's inside plus x. And when we run the code, what we have to do is we have to declare this function, which is going to create an object, which is going to have plus x's activation object inside of it as part of its scope chain, and then it's going to be returned. And then so when this gets invoked, so now that we call plus 42 with 1, so we say, okay, well, an execution context is created, the scope chain is loaded, which is going to be the global scope, and then plus x's activation object, and then its own activation object, which is going to have n in it as 1. When it looks for n, it's going to find it in its closest scope, and then it looks for x. It's not going to find it in its closest scope. It's going to have to traverse up the scope chain, and it's going to find it in the next one. Is that good? Yeah?
So can we access the activation object from userland? Like, could I return an
No.
activation object?
So it's like fancy internal stuff. It's like trying to get the prototype of a function, or sorry, the prototype of an object or something like that, in order to get like actual access. So I talked about this in a little bit, because I have another talk that's understanding the JavaScript object model, which I like, and I talk a lot about prototypes and whatnot. Sorry, I'm getting a little, so we can talk later. Okay. All right, I'll outline it. Was everybody on board with that? Are you okay? Yeah. So we're almost done. Trick questions. So here's a trick question that almost every JavaScript ninja gets at an interview. So basically, pretend that you're being interviewed and I'm the interviewee, or the interviewer. So you're the interviewee and I'm the interviewer. And I say, please read the following JavaScript code, and using only your brain compiler, tell me what the output is. So the poor unknowing ninja will almost inevitably answer 0, 1, 2, 3, 4, which is of course wrong because this is a trick question. The correct answer is actually 5, 5, 5, 5, 5. So the ninja will scratch their head and try to figure out what went wrong. And the answer, though, is in the scope. And the bug, if we're going to call it a bug, is right here. Function console log I. So if going back, we can see that we have this funcs array, and then we're going to loop over it 5 times, pushing a new function into the funcs array. And we're going to say, now again, starting at 0 through 5, we're just going to iterate over funcs, invoking the functions that we push onto it up here. Okay? So on each basically on each iteration of the loop that's up here, a new function expression is created and pushed into that array. And it holds a reference to the active scope at that time. So the reference isn't a snapshot. It's a reference. It's something that it can point to. So later when the function is invoked, it looks up the variable I, and it finds it at its current value, which is 5. Does that make sense? Okay. So how do we get the intended results? 0, 1, 2, 3, 4. Not too many people actually ask that. So you do it like this. Or more specifically, you do it like this. And we use an immediately invoked function expression. So this gets a little tricksy, which is why it's a trick question. So the IIFE is used to create a new activation object, which sits in front of the scope chain, and returns the function which logs the value of I. Okay? So the difference here is now the logging function is a true closure, as it holds a reference to the IIFE's activation object. The twist here is that the IIFE's activation object shadows the outer scope's variable I with its own variable I. And in this case, the I is the value of I at the time the function was invoked. Does that make sense? No? No? All right. I can slow it down a little bit. I wanted to make sure that I got it right, so I read it right off of my notes.
You could have did kind of the things.
Yeah. What you could have done, like my friend here just suggested, is here, where we said, actually here, where we take in the value I, we could have called that anything else. We could have called that, like typically it might be called II. It could be called X or N or something like that, and then we call it with I. So this is just making use of something that is called shadowing in JavaScript. So a variable exists that has the same name as a variable that exists higher up in the scope chain. So when we're looking for that variable, we find it in this lower scope, and so it's said to shadow the variable that exists in the higher scope. So basically, if we're just going to look at this, what happens is we're creating closures, not just functions. And so the IIFE takes in the value I at the time in that loop. So the first time through the loop, the value of I is 0. So I is going to be passed into this function, which is going to create that activation object, and it's going to have a value I of 0. And then so when we log it out, so when this function logs, it's going to look for I. It wasn't called with anything. It doesn't have I in its own activation object, it's going to have to go up the scope chain. And it's going to find the I that was in the IIFE's activation object before it finds the I in the local scope. Does that make more sense? Okay. Damn it! Right. These buttons are too close together. This is a user experience bit. All right. Last topic on this one. All right, so this is our last example. So if you remember our enumer function from a few slides ago, this is what it looked like. And it was good, but it wasn't great. For instance, some of the things that we can do is we can easily change some of the values that actually exist on the colors enumeration. So we can say, hey, yellow equals yellow. And then when we say colors contains yellow, we get true. We don't really want that. Also, we can just delete things out of our enumeration. So we say colors, after we delete red, we say colors contains red. And that'll be like, nope, doesn't happen because you got rid of it. And a really interesting feature is we can say, hey, colors, do you contain contains? And it'll be like, of course I do. Here it is. So it's not a true enumeration. So what we can do is we can fix it by using encapsulation made possible by closures. And so here's our new better enumeration function. So the big change here is that we're actually returning an object literal and not the actual enumeration. So we're saying, hey, here's an object literal that has a property called contains. You can ask it if it has anything in it, and it will tell you. And so what you'll notice though is that we're returning contains. We're returning this object literal here that has contains. And because contains is a function expression, this is now a function which is returned from a function, hence a closure. And so now, when we say, hey, colors yellow equals YOLO, when we say colors contains yellow, it's still going to be false. The way that works is because when we say, hey, does it contains, we say value, so we're passing in yellow, and we just look at values. But values was defined up here. And so it actually doesn't exist on this object anywhere. And so anything that's trying to look inside this object, because it can't actually look at the scope chain or the activation object of those things, it's not going to be able to find values. So that's where the encapsulation comes in. Also, colors contains doesn't contain contains anymore, which is pretty good. All right. Were there any questions about that better enumer? All right. Let's soak this in. All right. Good. All right. So, Amanda Blake, last slide, questions. This is a QR code which links to my LinkedIn account, so we can connect if you want to. Just use your fancy phone, read it, and then and connect with me. Also, here is a link to my talk. If you could please rate and review my talk. I really do hope to get feedback, good or bad, that I can make this talk any better. I want to make sure that if I were to give this talk again, it would be more understandable if it wasn't so today. So thank you.